So here's an algebraic solution to that extra credit problem about the lily pad doubling. So if we know that a lily pad doubles every day, and we know that at the end of 30 days a pond is totally covered, when is it half covered? And I already presented the logic solution in the form of a video, but here's an algebraic solution. So this looks similar to the problems that we have done with exponential growth and decay. So let's kind of address it from that viewpoint. Well, if x is we'll let y be, here we go. X is my time, and y is amount, and we'll just use percentage because we don't know how big the pond is, and we don't know how big the lily pads are, we don't know how many lily pads, but we do know percentage. So we know when time starts, we're just going to say that's the beginning of the month, but we don't know what percentage of the pond is covered on day 0. But we do know at the 30th day it's 100% covered. And of course what we want to know is when it is 50% covered. But kind of ignore that one right now. Alright, so this is kind of like the 2-point system, except there's no point here, so I can't make 2 points. But I do know something about the situation. I know it doubles. So that means b is 2. So what I'm going to do is I'm going to change this first to a decimal, and then I'm going to use y equals a times b to the x, or t. And I'm going to create a situation, or I'm going to create an equation there. So y is my amount, and that's 1, or 100 for 100%. But I don't know a. I don't know what I start with, so I'm just going to let that be a. But I know my b is 2 because it doubles, and I know it is doubled in 30 days. So what I want to do is I want to solve for a. So I'm going to do that by dividing both sides by 2 to the 30th power. And what I do not want to do is compute that, because that's kind of a mess. So it's 1 over 2 to the 30th. Well, that's my a. So now I can go back to this formula right here, and now I can say, well, I want to know when it's half covered. But here's my a, 1 over 2 to the 30th times 2 to the t, and I'm solving for t. So this half is my 0.5 here. So I'm going to divide both sides by the a, 1 over 2 to the 30th, 1 over 2 to the 30th. So now I have 0.5 divided by 1 over 2 to the 30th equals 2 to the t power. Solving for t, we're going to take, you can do either log, common log, or natural log. I'm going to do common log, and that, that lets the t come down in the front. So now I've got the log of 0.5 divided by 1 over 2 to the 30th equals t times the log of 2. And then, of course, I divide both sides by the log of 2. And I encourage you to type this in your calculator. And when you do that, you will get exactly t is 29. I think if you would have computed this way back when, and then use some value here, however rounded off, you'll get close to 29, but you won't get exactly 29. So this is by far the easiest way to do it. You may, I'm not going to do this for you, but you may also follow the same method by using PERT, realizing, of course, that b equals r to the t. So you have 2 equals e to the r. Using logs on both sides, you're going to solve for r, and then you're going to do the same thing we did here with p. And it's quite messy. You might think this is messy. I don't think this is very messy at all. The messiest looking thing here is 1 over 2 to the 30th. Otherwise, this is not a very messy formula. But when you use PERT, it's just a tad messier. So anyway, there's the algebraic solution worked out to If the lily pad doubles every day and by the end of the 30th day the pond is covered, 100% covered, when is it half covered?